In in today's video, I will discuss about linear variable differential transformer. So I will cover validity followed by the construction and how LED device work. So we are calling it LVDT. So let's kick thing off. Let's look at what it actually is. Remember, so this is a transformer, not just any device. As mentioned, it operates similarly to regular transformer. So when we say LVDT, we are getting into the specific how it works. Let's break it down like this. It is an electromechanical inductive transducer. Basically, it uses an inductor to convert linear displacement into an electrical signal. We can use this to measure things like weight, tension, and pressure in garments. And the actual measurement happens after detecting the displacement. So first, the device will convert the displacement into an electrical signal, and then we can use that signal into measure tension and pressure. So we can say that this LVDT converts something, which means it's converting displacement. To start with, here has to be some displacement happening. That is why it is usually worked as a secondary transducer. It is basically saying that the visibility will look something like this. Now let's talk about the construction. Look at the LVDT, which is like a transformer. Okay, in this transformer there are two wings. One is the primary, another is secondary. Okay, one is primary and another is secondary windings. However, there is a in this case we have marked in the primary winding. These are two secondary windings which we call S1 and S2. The secondary winding will stay here and is placed at a distance from the primary on both sides. Take a look. This is a single primary windings. Beside this, S1 and S2 will be placed on two secondary terminals, and the number of turns for both will also be noted here. The primary windings is connected in this way for specific reason. A transformer takes in an input signal and send out an output signal that stays the same. Here the primary side gets the correct input signal. Another important thing to note is that in a typical transformer, the core stay in place, but in this case, the core is movable. That is movable part. The core is movable. Okay. So you will see that it has a movable soft iron core that fits inside the primary and secondary winding. Soft core fitted primary and secondary winding. Check out this cross section view of an LVDT. The primary winding is both parts that are involved, and a second hand circuit on the side, which might or might not be here. The secondary winding is set up in a way that is output produced to opposite things. Secondary 1, secondary 2. The difference in the output of both is what gets converted with a suitable circuitry. So inside the stainless steel housing, you can see that they have provided this stainless steel housing for overall protection and more. It generates both electrostatic and electromagnetic field. Now let's look at how it works. The working principle is based on mutual induction. So if we have two different inductance, the induction produced in a coil B is known self inductance. Coil B has another coil which have called coil A placed right next to it. If there is a change in voltage, Faraday laws of electromagnetic induction state that there will be change in the magnetic field around it. So in this inductive coil, if we check the voltage across the resistance varying, and it will depend on the values here. If we keep the same values, the induction will occur here. That is why induction will be produced in A because of B, in a coil A because of coil B. So this kind of induction is called mutual induction. The working principle is the same as that of transformer, but the only difference is what we have. We connected the DC supply and are checking the resistance. Now we have directly connected the same supply here. If we hook up the supply, what changes will happen? We know how this kind of verification works. Here the positive and negative are together, and the amplitude, it is continuously varying. So there will be changing voltage here which is, there will be changing magnetic field. For that reason, if induction used in section A, something similar will also happen in section B. So that is the working principle. Let's see what it does. If there is a variation in the primary winding, okay, then there will be definitely be some output in the secondary as well. But the way this winding is connected, it is set up so that it work against each other. So if we look at the map here, and consider this as E2, then the overall voltage will be based on E1 minus E2. The working of this can be explained like this. There are three cases that will be depend on the position of the core. So the core can be in the center, or it can be close to S1, or if it is close to S2. Let's look at the first case. If the tap position is the center and it's a distance from S1 and S2, then the voltage across S1 and S2 will be 0. Okay. Let's talk about case 2. In this case, if we point the core towards S1, the current across S1 will be greater than area A2. Okay. If E1 voltage is higher, so the output will definitely be positive here. And in third case, if could move towards S2, then S2 will be greater. That's why E1 minus E2 will be negative. So in this way, we have three positions presented. If we simply supply it like this, the output will look something like this. We can get a position here and see the output. So in both cases, our output voltage stays positive because we have considered that valve should be at 0 position. If it is not a 0, we'll need to adjust it. So if we consider that particular condition as the reference position, we can calculate the magnitude from it, and our output will look something like this. You can see here. Now that was about LVDT, but let's see why it's called LVDT, which stand for linear variable differential transformer. The first part is linear because it is used to measure linear displacement. Basically it is based on transformer principles, so that why transformer comes at the end. For a variable well, there is a movable core already, you can see, and that because of that movable core, variable terms are used at the end of differential difference. So the difference of in the secondary voltage is considered here as output, that is we call a linear differential transformer. So don't forget that that is a position, so that according to position, okay, it is towards the positive and moves towards the negative. And initial position in case 1, when core is null position, it is here, that position. So that's all.